Hi viewers, in this video we will solve problem 4.2 from the book Applied Thermodynamics में कौन की anti stove. Here is the statement. Steam at 0.05 bar 100 centigrade is to be condensed completely by reversible constant pressures. Process calculate the heat rejected per kilogram of steam and the change of specific entropy. Sketch the process on a TS diagram and shade in the area which represent the heat flow. So the steam at 0.05 bar 100 centigrade is to be condensed completely. So initially the pressure that is given, that is 0.05 bar, but remember here is mentioned that the condensing process is taken place at a constant pressure. So throughout the process our pressures all process taken place as a one pressure line, that is 0.05 bar, and the temperature T1 that is equal to 100 centigrade. So after at a constant pressure, heat condensation is so heat rejections take place and condensation is occur. So our final stage is at the saturated liquid line, because when the condensation is occur, it will touch the saturated liquid lines of the TS diagram. So I will make it here. Let me show it. So this is the TS diagram for this process. So initially the first state point, the pressure P1 T1 lie in the superheated region, so it will be on the right side of this saturated line. So this is our state point 1. So after heat rejections and condensations take place, it will touch the saturated liquid line, because in condensations liquid will form. So this will be our state point 2. So the entropy at this stage is S1 and the entropy at this point is S2, and this is the shaded region where heat is supplied or rejected is taken place. Okay, now at initial temperature and pressure P1 that is constant throughout this process, the enthalpy at the superheated region 1 that is equal to H1 from the superheated steam table, that is 2688 kilojoule per kg, and the entropy S1 that will be equal to 8.768 kilojoule per kg Kelvin. Now the second state is at the saturated liquid line at a pressure that is equal to P2, and that will be equal to 0.05 bar. But I extract the portion of the steam table that is saturated liquid line values are shown at the corresponding pressures, that is in the kilopascal. So we will convert that 0.05 bar to the kilopascal when you are seeing the values is corresponding value in the steam table. You need to convert that into kilopascal. What you will do, you will just multiply this value with 100 and it will convert that into kilopascal. So that will be equal to 5 kilopascal. So at a 5 kilopascal from the saturated steam table, you will get that the HF1 value that is equal to around of 138 kilojoule per kg, and remember this HF value and this the next is the SF value, that is 0.4764 kilojoule per kg Kelvin. So this SF1 value is equal to S2. Why? Because our state point as a whole lie on the saturated liquid line. So the whole entropy will be equal to this SF value that we get from the saturated steam line. And similarly this HF value will be equal to H2 because of this reason. Now so the heat rejection that is taken place is equal to H2 minus H1. So what is H2? That is 138 minus H1, that is 2688. When you subtract it, you will get the heat rejections that is occur, that is minus 2550 kilojoule per kg. So this minus signs show that during condensation heat rejections taken place. Next we need to find is the change in entropy, S2. So what is S1 value? That is 8.768 minus 0.476. So you will get the change in entropy, that is 8.29 kilojoule per kg Kelvin. I hope you understand the concept behind it. For more such videos and solutions of the such problems, please subscribe my channels.